Alright, in this video we're going to solve linear systems by elimination. In the previous video we used graphing, and we learned that we can have one of three possibilities for a linear system. We can have one solution, and that's where the lines cross at one point. We can have no solution, where they would parallel and never cross, or we could have an infinite number of solutions, meaning that they're the same line, so they share all the points. So those were our three possibilities. Alright, so now let's solve by elimination. So the goal of elimination is to eliminate either the x or y term so that we can solve for either x or y. So right here, I have two equations. I have negative 4x minus 3y equals 6 and negative 8x minus 4y equals 8. The first goal is to match up the x terms or the y terms with the same coefficient but a different sign. So I know that's a lot to process, but basically what I want here, I have a negative 8x here, so I'm going to choose to get rid of the x's. I could get rid of the y's. I'm choosing to eliminate the x's in this case. So if I have a negative 8x here, I need a positive 8x right there so that they will eliminate. So I'm going to multiply this whole top equation by a negative 2. If I do that, that will give me a positive 8x right here. So multiply that top equation by negative 2, that would give me positive 8x. I'm just distributing a negative 2 in here. That would give me a positive 6y, and that would give me a negative 12, equals negative 12. So my new top equation is this one. It's equivalent, it's the same line, I've just multiplied all the terms by negative 2. Then my bottom line, this one, stays the same, so I'll write it underneath. Negative 8x minus 4y equals 8. Now, you can subtract the two equations or you can add them. I teach students to add. That way the sign that's in front of the term goes with it. So we're just going to add these every time. So now we're going to combine them through addition. So 8x, we just read the sign. 8x minus 8x is 0x. So basically they cancel. We'll just mark that out. 6y minus 4y is 2y. Negative 12 plus 8 is negative 4. So now I have a simple equation. 2y equals negative 4. I have one variable and one equation, so I can solve that. So I divide by 2, and I find that my y value is negative 2. So what we are saying is the y coordinate of the solution to this system is negative 2. So now that I know that y is negative 2, I can substitute that into either or any of the equations I have and then solve for x. So I'm going to substitute it back into that original top equation. So I'm going to write it again here. Negative 4x minus 3y equals 6. Now I know that y is negative 2. So I'm going to substitute in a negative 2 right there and rewrite this. So negative 4x minus 3 times y is negative 2, we found that before, equals 6. So work that out and then we'll solve for x. So negative 4x, negative 3 times negative 2 plus 6 equals 6. Subtract 6. I get negative 4x equals 0. Divide negative 4. And x equals 0 divided by negative 4, so x equals 0. So the solution to this system is the ordered pair 0, negative 2. There's one solution, they cross in one place, and that is at the ordered pair 0, negative 2. So we solve this system by elimination. Alright, now on to example 2. We are still solving by elimination. Last time we eliminated the x term, so this time, just to be different, we'll eliminate the y term. So this bottom equation, I have a negative 3y, so I need this top equation to have a positive 3y, just the opposite, so a positive 3y. To do that, I would need to multiply this top equation by a negative 3. Negative 3 times negative y will give me a plus 3y. That's what I want. So multiply this top equation, distribute that negative 3 in, here, here, and here. So that would become positive 12x plus 3y equals negative 3 times 6, negative 18. I just multiplied these terms by a negative 3. And then the bottom equation stays the same. X minus 3y equals negative 8. Now I simply combine the equations through addition. So 12x plus x, 13x. 3y minus 3y is a 0y, so it cancels. Negative 18 plus a negative 8 would be negative 26. Now I have a simple equation. 13x equals negative 26, so solve for x. Divide by 13, divide by 13, and I get x equals negative 2. So I know the solution to my system has an ordered pair with an x value of negative 2. So now I can take either of the equations that I started with and substitute in a negative 2. So I'm looking at these two equations up here. The easiest one to work with, you could choose either, but the easiest one is to plug in a negative 2 right there, because then I don't have to divide by negative 4 in my process. And as you work these, you'll see that you want to look for the easiest way. So that would be the easiest. That's what we're going to do. So I'm taking the x minus 3y equals negative 8, and I'm going to substitute in a negative 2 for that x. So I'll rewrite it that way. X is now negative 2 minus 3y equals negative 8. Solve for y. So I add the 2, negative 3y equals negative 8 plus 2 is negative 6. Solve for y here, divide by negative 3. So y equals positive 2. So the solution to this system, it has one solution, and that would be the ordered pair negative 2, 2. So an x value of negative 2, a y value of 2. If we got these two equations in slope-intercept and graph them, we would see that they cross at the ordered pair negative 2, 2. Now for example 3, negative 5x minus 2y equals 2, negative 10x minus 4y equals 4. So our goal here is to use elimination to solve the systems. So let's eliminate the x here. I have a negative 5x in the top equation and negative 10x in the bottom. So I need to match them up with opposite signs. So I need this one to be a positive 10x to eliminate with that one. So to make this a positive 10x, I need to multiply this whole equation by a negative 2. So once I distribute that negative 2 inside there, I would get positive 10x plus 4y equals 4, negative 4. Okay, then write the bottom equation, so negative 10x minus 4y equals 4. That didn't change, that's the same as it was before. Now combine the equations through addition. So 10x plus negative 10x is just 10x minus 10x, so 0x, cancels. 4y minus 4y is 0y, cancels. So my left side of my equation is equal to 0. There's nothing over there, so I need 0 as a placeholder. Negative 4 plus 4 equals 0. So I have 0 equals 0. That is true. What's left is true. My variables have canceled. So this one is an infinite number of solutions. Infinite number of solutions. So in other words, these are the same lines. They lie on top of one another. They share every single ordered pair to infinity. So infinite number of solutions. Example 4, last example. So looking at these two equations, I need to eliminate either the x or the y. I see an opportunity here to eliminate the x, so that's what we're going to do. I need a negative 10x right here in order to cancel with that positive 10x. So I'm going to multiply this top equation by a positive 2. So I do that and I get the new top equation is negative 10x plus 8y equals negative 2. I just multiplied all of these by positive 2. The bottom equation stays the same. 10x minus 8y equals negative 6. Combine the two equations through addition, so we just keep the signs. Negative 10x plus 10x, 0x, cancel. 8y minus 8y, 0y, cancel. So the left side of my equation is equal to 0. Negative 2 plus negative 6 becomes negative 2 minus 6, so negative 8. So my variables canceled. No x, no y left. So I evaluate what's left and see if it's true or not. 0 equals negative 8 is not true, so this means no solution. So in other words, these two lines, if I were to graph them, they would have the same slope, different y-intercepts. They never cross. Therefore, there's no ordered pair that they share. Therefore, there is no solution. All right, we're going to go back to example 1 and work this problem eliminating the y's. I want to show you that sometimes you have to multiply both equations. So if the first time we worked this, we got rid of the x's, and that was fine. We only had to multiply one equation. We multiplied the top equation by a -2. But had we eliminated the y's, and again, in some cases this is your only option, you end up having to multiply both equations. So I have a -3 and a -4 coefficient here for the y. So the smallest number that 3 and 4 go into is 12. So I want one of these equations to have a positive 12y and one to have a negative 12y. I can make that choice. I'm going to choose to make the top one have a positive 12y. So to do that, I have to multiply this top equation by -4. Then if I have a positive 12y here, when I'm done, I need a negative 12y here. So to do that, I have to multiply this bottom equation by a 3. So when I do that, the top equation in red becomes positive 16x plus 12y equals negative 24. The bottom equation becomes negative 24x minus 12y equals positive 24. So then I eliminate, I need the x here. I eliminate like I normally would. So I eliminate these, or combine them through addition. So 16x minus 24x is negative 8x. 12y minus 12y cancels. That's what I wanted. I got rid of the y's, and I had to multiply both equations to do that. Equals negative 24 plus 24 is 0. Divide by negative 8, and I get x equals 0. The same thing we got in the first place. And then I could come in here and plug into either equation. I'm going to plug in an x value of 0 in that top equation to get the y now. So negative 4 times 0 is 0. Minus 3y equals 6, so I can just get rid of that. So negative 3y equals 6, divide by negative 3, and I get y equals negative 2. So the ordered pair is 0, negative 2. That's our solution. Same thing we got the first time, but I wanted you to see that sometimes you have to multiply both equations by a number. It's not always the case where you can multiply only one.